Hello, everybody. I will be talking to you today about foundations and history of the semantic web. My name is Pascal Hitzler. I'm a professor at Kansas State University, and I've been on the semantic web circuit for, well, a bit more than 20 years already. So I've seen some of the history myself, and I want to tell you about it. If you want to read up about a lot, but not all of the things I'm going to talk about today, it would be this paper, where I essentially talk about the status of the field from a historic perspective. But of course, that paper is from 2021, so kind of the newest years are not covered there. What is semantic web? First of all, let's kind of clear some definitions. Semantic web is actually a field of research. So it's not a concrete artifact. Like artificial intelligence is a field of research rather than a concrete artifact. Semantic web technologies is sometimes used as a phrase to refer to methods. And so what is the field about now that we know it's a field of research? Well, and here you could say that opinions already differ, or there's different shades in the community how they kind of understand semantic web. And one perspective would be that the semantic web field is about creating the semantic web as an artifact that extends the World Wide Web. The second point is that semantic web as a field is about developing and the use of principled methods and tools for data sharing, discovery, integration, and reuse, be it on the World Wide Web or not on the World Wide Web. And that's a more restrictive perspective, which would be that semantic web is about foundations and applications of things like ontologies, linked data, knowledge graphs, using W3C standards like RDF, OWL, Sparkle at their core. And I will go through all of those things, at least briefly, to give you a kind of brief foundations while we go through the history of the field. If you want to read up on some of the technical background, there's a textbook here which I wrote. The textbook is in fact already 15 years old, but it's still pretty current in terms of content. So let's look at history. And you know how you frame history in any case, it's up to the framer to a certain extent, just has to make sense. So I'm making some artificial boundaries, but it helps discuss kind of some main movements in the community that have happened over the years. And I'm going to start with 2001. Why I do that comes in a second. And we can probably say there's 3 phases plus a new one. And these 3 phases would be ontologies, then linked data, then knowledge graphs, and then the newer developments that are happening right now about large language models. And in fact, you can phrase this as thesis, antithesis, synthesis, the first 3. And I'll talk about that and why I think that makes sense in terms of understanding how the community has developed. So the beginnings. I put the beginnings at 2001, and really it's an arbitrary date, but it's a date often used. And the reason is that in 2008, there was a Scientific American article, which is referenced here, and that really kind of got the buzz going. That created a lot of wide visibility for semantic web as an idea. Now, that article, if you read it now, 25 years later, that article talks about agents on the web or the internet that seamlessly and ad hoc interact with structured data or information, knowledge encoded on the web, solving all kinds of tasks automatically and autonomously. And yes, kind of, we may be entering this space again with large language models and new developments in AI, but 25 years ago, that was kind of completely up and out in the air. And in particular, it was not about deep learning or large language models. It was a completely different underlying idea. So that was rather futuristic, of course. And that, as I said, got the buzz going. Now, of course, it did not really start in 2001. There was earlier work. I listed some of the things below, even if you want, going back to the 60s, perhaps, which are precursors of this effort. You always stand on the shoulders of giants, of course. All right. So what was the idea, or one of the ideas that was floated during these early years and alluded to in the 2001 article, which I mentioned? Well, there was one idea which was also not entirely new, but really kind of buzzed up during that time, and that was ontologies. And what are ontologies? Well, I have here a little graphic, which is really a depiction of some of the things an ontology is. And if you look at this, and this encodes foods and recipes and things like that, then you see, for example, well, if you have something like a recipe, then on the web or wherever you think about it, then it may have a difficulty level, right? Which is expressed as a string like easy, intermediate, or whatever. Or a recipe may have a classification, which you could also express as a string, for example. So in that sense, what you see in front of you is a schema for data graph, in fact. And under the hood, ontologies are much more complicated. They're not just, these classes and relationships. They're more than class hierarchies, which also play a role here. You really use formal logic for the representation, but I can't go into this. That would be much too technical for this introductory talk. But you get the idea. It's kind of a schema with general classes that tell you how to organize data, like data about real recipes on the web, for example. And that's the idea behind an ontology. And that idea was kind of new. They were around before that, but ontologies matured, in particular during this time. There was a lot of buzz about it. The gene ontology, Snowbed as an ontology, which is for medical institutions primarily. And also some standards matured and essentially were released during that time, in particular through the World Wide Web Consortium, W3C, which kind of also governs HTML, standards for websites and things like this. And the three big standards here, I think, which are foremost to mention, are OWL for ontologies, the web ontology language, RDF, resource description framework, which is for the data according to these ontologies, and Sparkle, which is a query language. Again, we can't go into too much details here, but they kind of started around that time. And also during that time, so early 2000s, there was a very active and diverse community growing. A lot of it in Europe because there was more funding available there, which was very targeted, but also in application corners, and particularly here in the US, and also a strong industry interest and community, startups, but also big companies getting into using ontologies. Well, and what are they using it for? And I mentioned already earlier that one of the things about about semantic web as a field is that you can say it's tailored towards data integration, sharing, discovery, and reuse. So how does that connect with these data schemas? And really, if you're familiar with database-based data integration, then the idea of an ontology is the idea of a database schema. It's just that it has a different look and feel as an entity than a database schema, although, of course, the ideas and also the technicalities are somewhat related. The idea is that if you have one schema, but then you have a lot of data, say, coming from different sources, different websites with recipes, then you can map them all into one schema, and thereby you integrate the data. So that's the idea behind ontologies, or one of the ideas behind ontologies. The development of these ontologies also, or the idea behind these ontologies at the very beginning was that you want them to be easily usable, easily mappable to, easily reusable for new application contexts and so on. So that was one of the key ideas. Make these ontologies that will work for other people as well. And what turned out actually after a few years was that's not just working that easily. It turned out that these ontologies, in particular once they got to a certain size, were hard to understand, hard to maintain, hard to reuse, expensive to produce. And then discussions about quality of them, also the question, what actually is quality in that case? And arguably, it often seemed easier then to make a new ontology from scratch than to try and understand a previous complicated ontology and adapt it to requirements. And of course, it was a little bit of a showstopper. And that's why I said that was the first phase. There was the thesis that ontologies are really helpful. And then there came the antithesis as a reaction to things that didn't work so well. And that antithesis gets the heading linked data. So what was the idea there? Well, essentially the idea is we still look at data graphs underlying these schemas, but really we kind of almost forget about the schemas. We don't care about the schemas. We don't care about the ontologies. We just put our data in this graph format in a very ad hoc way. We do that and publish the data, or at least a queryable point on the web, which you can query that data. And then also, and that was the key idea here, make sure your data graph has a lot of links to other data graphs, to other linked data sets. And the idea was that that will create a huge network of smart data. There was a term used back then that will kind of solve data management problems because kind of through this dense network, data becomes kind of self-explanatory. That was kind of the idea. So there was little concern at this stage regarding what is a good schema? How do I exactly organize my data graph? It was kind of throw it out, fix it later, and it will almost magically be self-explanatory. Now, of course, I would say now, and some people were saying back then, including me, it's not going to work like this, right? And I just want to give you a little piece of a data graph. It's very small piece of the YouGov graph made back then, and there's nothing wrong with it. I think it's actually well modeled. The problem is just that if you see this in front of you, and this is a depiction of it, it's hard to make sense of this, in particular if this is part of millions of nodes and connections. This little piece of the graph says that Nancy Pelosi voted yes for the Affordable Care Act, right? And yeah, it's complicated. And the point is not to say that something is wrong here. The point is that it's very difficult to understand a data graph if that's all you have to go with it, right? It's not impossible, but it's a huge lift. And that's not good for reusability, right? Or for understanding, or for making sure that, well, if I have in my data graph Kansas City and you have in your data graph Kansas City, that we mean the same thing, because very often they're not. This is another piece of a linked data graph, right? Actually, the newer term is knowledge graph. I'm going to come to that. This is out of Wikidata, which is fantastic, right? But if you look at this, no, this is not self-explanatory, right? So there's a problem if you just rely on these data graphs to be self-explanatory. This, by the way, talks about Eero Hiivanen, who has been in the fields of semantic web for longer than I have been. This is another visualization by Christoph Janowitz. He did that 13 years ago. And the only thing he did there was, at that stage, he was looking at the web, looking for all the data that was put out there in this format, in this linked data format, and grabbing only the data that had geocoordinates attached to it, longitude and latitude. And for each of such data piece, he put a dot on an empty screen, and out comes the world map. There's no map underlying this. It just appeared, right? And I just use this as a visualization for, well, that's a lot of data. And that's only the geotag data, which is only a fraction, right? So, you have all this all kind of in a kind of convoluted format, because that's kind of makes sense, but it's difficult to understand. And no, this is kind of not really self-explanatory. All right. So the linked data effort then essentially ran into a similar wall than the ontologies effort. Easy reuse, well, okay, some problems were really kind of solved. Like, syntactic things got solved through standards, for example. It turned out that, yeah, these kind of graph-based data formats, they really have a lot of virtue for them. But still it was still a major lift to reuse data and so on, although it was significantly easier, right, than not having these joint conceptualizations, like having a data graph rather than just a database, which can be, all shapes and sizes, for example. So then there came essentially a new thing that didn't land like a big splash immediately, because it was more kind of a softer movement. But there was a new buzzword that appeared on the scene, and the buzzword is knowledge graph. Now, the knowledge graph buzzword really is something that Google dropped. And at the same time, they essentially said that a lot of the Alpha backbone is actually, data backbone is actually run by knowledge graphs. Of course, for those people familiar with the semantic web, they kind of realized pretty quickly that, well, this is very close to linked data, very, very close to linked data. So Google Knowledge Graph. And by the way, you can have a glimpse of the Google Knowledge Graph by querying for well-known terms. Like you query for Finland on google.com. And then what you get is all your website hints for Finland. But one of the things you also get is a so-called info box, which you'll notice. You may have noticed those. And that's a glimpse into the Finland node in this knowledge graph. And in particular, this is a graph because at the bottom you usually have a structured list with which you can navigate to other pieces in this knowledge graph. Like, for example, Finland has a capital, Helsinki. And then if you click on Helsinki, then the next page has the website queries, but also has Helsinki as an info box. So you just traversed through the knowledge graph from the entity Finland to the entity Helsinki, and the relation was like a has capital link, right? And then you can keep going and go through neighborhood, for example, to a next one, which would be Kampi. I hope that's how you pronounce it, which would be a neighborhood of Helsinki. So you traverse the knowledge graph, or let's say you probably traverse the simplification of the Google Knowledge Graph, because I'm pretty sure the knowledge graph is more complex than what they're exposing here, simply because, well, I know what you need to put into knowledge graphs, and this is very simplistic visualization of the key pieces. But if you just take the simple kind of visual which we have the knowledge graph, then kind of you can look at kind of what's connected and say, so there's probably something like a country class, and every country has a capital, which is a city. Cities have neighborhoods, which may be districts. Cities have populations, which are numbers, and so on. So you can see there's kind of a very simple schema going on here, which is underlying this, but not necessarily exposed. Now, a good schema is critical for reuse and for easy reuse. That was one of the things that came back during the knowledge graph period, sometimes explicitly, sometimes implicitly, but the importance of a good schema. Now, what you see here is not a good schema, and that's probably because it's just simplified out of kind of navigation on the Google Knowledge Graph, which is visualized to us. But this is kind of too simplistic. Like, for example, city population, you really need to know what point in time you're talking about, because population changes every time, right? And depending on the purposes, it's even more complicated because nobody actually counts people in cities, or not in a way that you would actually get a real number which would account for the population, kind of when exactly is somebody moving in or out, right? Plus, you never can reach everybody. So there's always at least some statistics involved in population numbers. And then the exact statistics you use for doing that gives you different numbers, right? So it is actually a very complicated relationship between city and number, and not just a has population relationship. And depending on what you want to do with your knowledge graph, your schema needs to account for that, right? Because you may, if you're a statistics person, right, or a researcher, you actually may need to know what the statistical method was to assess the population number. But then in other cases, like if you're just kind of want the ballpark number, right, you can get it from the Google Knowledge Graph by their simplified perspective, which they expose to us as the humans. All right. This is a paper from 2019 with authors from big companies, Microsoft, Google, others, who were talking about the industry scale knowledge graphs, which they have to power what they do internally. And, you know, like a lot of good data management, I tend to say data management is at its best when nobody notices it's there, right? So that doesn't necessarily mean that you rub it into everybody's face as long as your website actually runs and does what it needs, or your system or your application or whatever. All right. So what was the similarity and differences between knowledge graphs and the linked data which we had earlier? I mentioned one of them already, which is the third one here, renewed consideration of schema quality. But there were other differences as well. One is that linking was de-emphasized. So in the linked data world, it was kind of you link your data graph to other data graphs, and then kind of you will get meaning out of this. It will become self-explanatory. That was kind of dropped, and that made sense to me to drop that. So linking was de-emphasized. Also, open data was de-emphasized. The big thrust during that time was actually on like companies big and small, right? Putting graphs together, but they were not giving you the exact graph. They were giving you an approximate view, you know, appropriate for the user. So openness of the graph was de-emphasized, while linked data really was driven by having graphs on the web. So usually, well, or very often, people refer to as linked open data rather than just as linked data. I mentioned already renewed consideration of schema quality. So that brings ontologies back into the picture in a more principled way, but also then tighter and central control. So it's usually one entity or a consortium which controls the graph and updates, and links and so on, because the community realized you need that, right? Because otherwise it's just too chaotic and not really useful. And there was also, I think, a clear transition from academia and industrial research into industry proper, in particular, big companies really running off the graphs as they report. So the goal here behind these knowledge graphs is to produce a flexible, extendable, user-friendly, but in the end, rather tightly controlled repository of integrated reusable data. And the format of choice is that of knowledge graphs, right, of data graphs with ontologies as the schema underpinning them. All right. So thesis, emphasis, synthesis. You get the idea kind of why this kind of framing is one you can do in this case. So lastly, and it's just a few slides, I want to talk about some of the new stuff. In particular, since 2023, there's new developments. And of course, a lot of things these days get influenced by the very rapid development in artificial intelligence. Deep learning has been around for, almost 20 years now as well. And of course, done a lot in different areas and made a lot of breakthroughs. And the newest breakthrough here is large language models. And you've probably used ChatGPT and other things like this. And this is a very interesting point for an opportunity for the semantic web community. Essentially, creating ontologies and knowledge graphs, right, or both in conjunction, is quite a heavy lift. It's a lot of work doing that. You need experts on kind of how to use ontologies and knowledge graphs. You need experts on the data sources who really understand them. You need experts who understand the application domain, right? Unless it's something that is completely understandable for everybody, right? But even if we talk about fine-grained city population data, right, you probably want a statistician in the mix who can kind of help you organize the different ways of doing statistics for getting population data. So you need a lot of experts, and then you need to put this all into an integrated data graph. And yeah, that's a lot of work. Even making a good ontology by itself is a lot of work. So it's very costly because you need a lot of experts in the mix to do that. And that has always been a bottleneck for the semantic web community. So essentially, to the extent that it was mostly worth it if you had a big application context with a variety of contexts, like having a big company and putting their data backbone into this format and then spinning off all kinds of applications from it. Like, for example, that's the added value proposition here. But for kind of smaller purposes, the question was always kind of, is it worth going through these complications if the project dies after 2 years, right? Or you want to make a feasibility study, or you solve a single purpose problem, right? And don't need to apply the data to other problems as well, right? So, and sometimes it's just easier to get funding for doing something kind of in a less principled way now than doing it a principled way, which, this benefit will not project from, but only the next one. So one of the bottlenecks is the expense of doing all this. So, and here's the promise of large language models. Now, large language models, they're really great, right, for some things. They suck at other things. Like, for example, you never know when they throw nonsense at you unless you actually understand the issue, which means you need the experts again in the loop, right? However, they're doing a really good job drafting stuff. You may not ask them to write a cover letter for you and then send that cover letter out without proofreading, right? That's probably a recipe for disaster. But if you get into the flow of asking it for a cover letter and then going through it, correcting, and then sending it out, it's probably going to save you a ton of time. And there's a similar idea here now in ontology and knowledge graph design. So rather than having all these experts starting from scratch or from pieces they already have from other places, or rather than trying to understand a complex ontology, because understanding a complex ontology is probably about as much work as making it yourself, and understanding and adopting it. The premise here is that large language models may be able to help draft you stuff of sufficient quality that then using this, And making it really good quality is going to be much less work than doing it from scratch, similar to kind of working with a cover letter. And if you want to read up on some of these arguments, there's a link to a paper on this slide, which is actually from this year. It's still in preprint, so I believe so it will be published later this year, because there's a kind of extended discussion there, and there's a lot of momentum in the Semantic Web community right now to go in that direction. All right, so what's the status? Knowledge graphs are currently everywhere. They're also part of other efforts related to deep learning-based AI. For example, you may have heard about RAG in the context of kind of making LLMs make fewer mistakes by hooking them up with knowledge graphs, right? Because they have reliable data in some way. So, for example, there's a big stream of things happening there as well. The NSF Proto-OKN program, which is actually why I'm actually here for this recording, and many others, also significant efforts in Europe. There's a lot going on. LLMs I mentioned promise a significant acceleration, in particular promises to address a main bottleneck in ontology knowledge graph engineering, accelerating it. So that's really cool. And yeah, I mentioned the RAG piece already. So it's exciting times, right? The field is, if you go with the 2001 starting point, almost 25 years old, but it's still very current, very active, very much worked about. The industry uptake is there, so it's very exciting to be in that context. And thank you all for the attention.